Okay, in this portion, this is problem 1 from the practice sheet, and it's an irregular shaped area that we need to determine what the area is. So you can see I've drawn some construction lines on here to indicate how we're going to break this up into manageable areas. So I've drawn this line. That gives us a rectangle over here. We can determine the area of this fillet to subtract it out from this rectangle. We can determine this area of this rectangle, subtract out this triangular piece, and then determine the area of that, and then add them all together to get the area inside the dark line. So the first thing we need to do is determine what this distance is from this point to this point, which is going to be 409.08 minus our 83.19, gives us a distance of 325.89. So this distance is 325.89 feet. And then over here, we've been told that everything is right angle. We know this radius is 160 feet, so our tangent length of this curve is also going to be 160 feet. So if we say 307.35 plus 160 gives us a distance of 467.35 feet, and that is for this line from here to here. So then to determine the area of this rectangle, we use 325.89 times 467.35 gives us 152,304.69155 square feet. Then to find the area of this fillet, we first need to find the area of this rectangle, and then we can subtract out the area of this segment of the circle to leave us this fillet area. So if we say 160 times 160 equals 25,600, and then we know that the area of this segment of the circle is going to be 1/4 of the total area of a circle with a radius of 160. So we know the formula for finding the area of a circle is pi r squared. If we divide that by 4, that will give us this segment area here. So if we say pi 160 squared divided by 4 gives us an area of 20,106.193, and if we subtract that from our 25,600, we get 5,493.807. So that is this fillet area. So if we take our total area of 152,304,69155, subtract out our 5,493.807, that gives us a net area for that rectangle of 146,810.8845 square feet. So that is for this area here. Then over here we've got our width. We know our length is going to be 148.75 plus our 80 feet is 228.75. So that's from this to here. So if we say 338.21 times 228.75 equals 77,365.5375 square feet. We need to find the area of this triangle to take it out of this total. We know that it's 80 foot by 80 foot, and the area of that is going to be 1/2 the base times the height. So we say 1/2 80 times 80 equals 3,200. And if we take our 77,365.5375 minus 3,200, that gives us a net area of 74,165.5375 square feet. And that is for this rectangle. That leaves us one more to do, which is this one. And that's going to be our easy one. We've got 143.38 times 83.19 gives us an area of 11,927.7822 square feet. So now we just need to add all of our numbers together. So if we say we've got 146,810.8845 plus 74,165.5375 and 11,927.7822. That gives us a total area of 232,904.2642, and we wanted that area in acres. We know that there's 43,560 square feet in an acre, so that tells us that we have 5.35 acres. And that's our final answer. This is problem 3 from the area 1, from area 1 practice 1. And we need to determine the volume of this excavation, including this ramp, and they want the answer in cubic yards. So we know the volume calculations are length times width times height. So in this case, we can divide this into two areas, one being the main part of the basement, and then we can calculate the ramp area as a separate area and add them together. So in this area, we know we have 100 feet by 84 feet by 12 foot deep. So we're going to say 100 times 84 times 12 gives us an an area of 100,800 cubic feet, excuse me. We'll convert this to cubic yards when we're done. Then for the ramp area, it's 100 feet long, and it varies from 12 feet deep here to 0 feet at this point, and it's 20 feet wide. So for this, where it's varying from 12 feet to 0 feet, we can use the average depth of that, which is going to be 12 divided by 2, or 6 feet. So for this area, we can do 100 times 20 times 6. And that gives us an area of 12,000 cubic feet. So then, to find the total volume of this, we would just add those together. We have 100,800 plus 12,000 gives us a total volume of 112,800 cubic feet. And we know that for every cubic yard, there is 3 feet by 3 feet by 3 feet. So that makes 27. So we're 3 feet by 3 feet by 3 feet. So 3 times 3 times 3 equals 27 cubic feet in 1 cubic yard. So if we divide our 112,800 divided by 27, that lets us know that we have 4,177.78 cubic yards of volume in this excavation. This is problem number 5 in the Area Volume Practice 1 handout. And it's an oblique triangle, and they want us to determine the area of the triangle in acres. So to do that, we know 2 sides and 1 angle. So we can use the law of cosines to find that. So if we say that this is angle A, that would make this side A. If we say that this is angle B, that would make this side B. And if this is angle C, that would make this side C. So the law of cosines, says that, so this is the cosine law. Says that A squared is equal to B squared plus C squared minus 2BC cosine of A. So we can substitute that in. We know then that A squared is going to be equal to B squared, which is 1181.77 squared, plus C squared, which is 1666.60, minus 2 times B, which is 1181, times C, which is 1666.60, times the cosine of 29 degrees, 10 minutes, 43 seconds. So from that, we can find out that A is equal to $857.2704 feet. So this distance here is going to be 857.2704. So now we know all three sides and one angle. We can use the law of sines to determine one of the other angles. The law of sines, or the sine law, says that A over the sine of A is equal to B over the sine of B is equal to C over the sine of C. So we know that A is 857.2704, and we know angle A, so we can say the sine of 29 degrees, 10 minutes, 43 seconds is equal to, and let's just find the angle B. B is, side B is 1181.77 divided by the sine of B, and that tells us then that angle B is equal to, so angle B is going to be equal to 42 degrees, 13 minutes, 40 seconds. So then the angle here at C is going to be equal to 180 minus 42, 13, 40 minus 29 degrees, 10 minutes, 43 seconds. So this angle is going to be 108 degrees, 35 minutes, 37 seconds. Now then, to find the total area of this, we need to find this height, because it's going to be 1/2 the base times the height. So to find the height, we need to square up a line where this is a 90-degree angle. So in order to do that, we need to determine this angle, because we want to find this distance here, so that we've got the base times the height. So this angle is going to be 180 minus our 108, 35, 37, which is equal to 71 degrees, 24 minutes, 23 seconds. So we need to find our height, which is this line here. We know this angle, we know our hypotenuse distance of this right triangle, so that allows us to find this, knowing that with the sine of this angle is equal to the opposite divided by the hypotenuse. So if we say that the sine of 71 degrees, 24 minutes, 23 seconds is equal to our opposite side divided by our hypotenuse, which is 857.2704. That tells us that our height of our triangle is 812.5238. Okay. Now then, the area of the triangle is equal to 1/2 the base times the height. So that is going to be 1/2 our base, which is 1181.77, times our height, which is 812.5238, which gives us an area of 480,108.1256 square feet. And again, we know that there's 43,560 square feet in an acre. So that gives us an area of 11.022 acres.